Good afternoon everyone, welcome to the channel. In today's video I want to talk about another clustering technique which is known as DBSCAN clustering, and the full form of DBSCAN is density based spatial clustering of applications with noise, which is a huge name. And basically this clustering works well for dataset where clusters are kind of dense rather than scattered. So let's see how this works with an example using Scikit-Learn. So as usual, at first I want to import the libraries. Okay, so for this clustering I need NumPy, then matplotlib, then from sklearn import data sets. Import DBSCAN, and finally, sorry, I made a mistake. From sklearn import matrix. So these are the required libraries. Now I want to create a few data using make moons object of sklearn datasets. So this is how it can be done. So X will be the features and Y will be the generated labels. So dataset dot make moons, and number of samples, let's say 500. Shuffle will be false. Noise 0.07. So random stat will be 42. Let's run it. Now let's check the shape of features and labels as well. Y.shape. So there are two features, and 500 is the total number of samples and 500 labels as well. Okay, now let's visualize data. So plt.figure, fixed size 10:6, face color azure. We can create a scatter plot and all rows and first column, because there are two features, then all rows, second column. C will be Y, so Y is this, all the labels, and S50 sample size, and let's say CMOP will be copper, and we can also mention x label, x-axis, font size 20. Let's copy. This will be y-axis. Let's say title. What can be the title? Let's call it data partitions. And font size, I think it's better to make 25 and this 30. And plt.legend. We need to provide an asterisk. Then we can call legend elements. Call title partitions. Font size 20. Title font size, so this like this 20. And bdocs to anchor 1.1, 1.24, 0.35. Okay, sorry, elements. Let's see if it works or not. Yes, it works. So this SC legend elements part does some kind of unpacking operation from the available labels. Okay, so this is how our make months dataset is looking. So this how to say concave, I guess concave is looks like one cluster. This convex portion looks like another cluster, but this is not a clustering outcome. Sorry, partitions. DION partitions. So this is the generated dataset we visualized. This is not a clustering outcome. We will see that later. Okay, so we can see in these two clusters data is quite dense. They are not scattered. There's not a lot of gap. Okay, so now we can perform DBSCAN. Clustering. So DBSCAN clustering. Control C. Let's call it case 1. You will understand later why this is case 1. There will be case 2 as well. Okay, so this is case 1, DBSCAN clustering. Okay, so we can write DBSCAN and provide two parameters. One is epsilon, another is minimum samples 5. So epsilon is basically a radius, neighborhood radius, some kind of, and within this neighborhood radius, if at least 5 samples are present, then for a particular point then a particular point will be considered a core point. So within this distance, within this radius, if at least 5 samples are present, so this distance is obviously from a sample, then within that circular region, if 5 samples are present, then that sample can be, then that particular sample can be considered a core point. Okay, now we have to fit our data. So this is our data, and then we can obviously get the labels like this. So DBSCAN. Okay, now let's check the unique labels. So we have 0 and 1 predicted labels after we fed in this data to DBSCAN, and we can also check the counts of the unique labels. So at first let's provide the known criteria, which is y. So return counts will be true. So 250. So each label is present 250 times, and same thing can be done for labels as well. This is also 250. Now we can compare these two by calling this all method, and it returns true. So basically that means all the data points of individual cluster have been predicted correctly by DBSCAN, and we can see this by calling accuracy. So first we need to provide the known results, which is y, then the predicted results, and you can see the accuracy score is 1. So everything have been predicted correctly. Now we can obviously visualize them. DBSCAN clustering results. Okay, now let's copy and change a few things. So here this will be labels instead of y. Let's change a few other things as well. Let's select different color and see maps. Instead of data partition, this will be DBSCAN clustering results, and this will be what to say, let's say clusters. Yes, I think that's enough. Okay, so this is the DBSCAN clustering outcome. You can see this is one cluster, this is another cluster, and they look exactly like the original partition. Okay, now I mentioned it case 1. Now let's see what happens if we do not choose these parameters appropriately. Then what happens? Okay, so in that case, I want to Okay, so I think let's copy to save some time. Mention a heading as well. From DBSCAN clustering case 2. Okay, just mention 2. This will also be 2, and I want to change this EPS, so radius. So I have to change it by little, and so I have reduced it from 0.2 to 0.15. So now the radius gets reduced. So now 5 samples need to be present within this radius for a particular point to be considered core point. Previously it was 0.2, and let's run it. We can obviously do all the things as we did previously. Now this will be levels 2. Okay, now let's see the difference. Previously we got 0 and 1, which is what we expect since there are 2 partitions. But now after changing it a little bit, 0.05, we got -1 as a level. So in DBSCAN clustering, -1 is assigned when a data point is considered noise. That means within this radius there is no neighbor. This whichever particular sample has been assigned -1 doesn't have any neighbor within its radius. That's why it is considered a noise. Let's run the other things as well. So np.unique, we can see the known criteria again. Return counts is true, and labels 2. Return from this will also be, sorry, this is labels 2. So we can see 249 zeros, 249 ones, and 2 has been assigned as noise, and label is -1. So for this particular reason, if we run this line of code again, this time we will get false. Previously got true, so true, now false, and accuracy will also not be 100%. So matrix dot accuracy levels 2. Now it has reduced 0.996. So let's visualize the DBSCAN clustering results. Visualize case 2. Let's just copy and change few things. Control C. 222. This should also be 2. Change this as well. Z. Just mention case 2 and case 2. I think it's okay. Okay. Now I want to show the previous 2 figures quickly. So this is the visualization of the generated data. And when we selected 0.2 radius, we got perfect predictions by DBSCAN. So the same clusters match completely with the generated data. And when we reduced the radius a little bit, we got few noise. And if you see this point and this point, now they are treated as noise. So noise has level -1, which is dark blue. So this is treated by level noise. This is treated as noise points, because these are situated little bit farther than 0.15 from its neighbor. So probably this neighbor, this neighbor. So in case of when we want to apply DBSCAN clustering, so we have to choose these parameters wisely if we want to avoid noise. Okay, so that's the end of this video. Thanks for watching.